Alright, so we finished all the three parts. Let's now look at example 6. A 2 microfarad capacitor is charged to a potential difference of 12 volt. The wires connecting the capacitor to the battery are then disconnected from the battery and connected across a second initially uncharged capacitor. The potential difference across the 2 microfarad capacitor then drops to 4 volt. What is the capacitance of the second capacitor? Well, did you understand this problem? Do you want me to show this to you how this is done? Well, let's see. Well, this is the given situation. You have a 2 microfarad capacitor and you connect it across a battery to charge it. Now this is a 12 volt battery and I need only connect it for a fraction of a second, right? Now the connections are removed and then this is now connected to a second capacitor. But when you do that, make sure that the positive of one capacitor is connected to the positive of the second capacitor and the negative to the negative. Look at that. This is what is done. A capacitor is charged on a battery, which is a 12 volt battery, and the connections are removed from the battery and then connected across a second capacitor. Now you can see these two capacitors are actually now in parallel, and we are told that the potential on the first capacitor, on the 2 microfarad capacitor, now falls to 4 volt. That means what will be the potential difference across the second capacitor? They are in parallel. They both will have the same potential. Alright? Okay, let's do the problem now. Well, you have a mental picture of the problem now. We have a 2 microfarad capacitor connected across a 12 volt battery. Alright, what is the amount of charge that the capacitor will get from the battery? You see, the amount of charge will be Q equal to CV, that is 24 microcoulomb. So when that capacitor, 2 microfarad capacitor, is connected across the battery, the amount of charge the capacitor derived from the battery is 24 microcoulomb. Now, that capacitor now has an amount of charge 24 microcoulomb, is now going to share that with another capacitor. When the 2 microfarad capacitor is connected across a 12 volt battery, the charge transferred to the capacitor is given by Q equal to CV. That will be 2 microfarad times 12 volt is 24 microcoulomb. Now after disconnecting from the battery, this capacitor is connected to a capacitor of capacitance C. We don't know the value of C. There you got. This is Q1, our original 2 microfarad capacitor. It is now connected across a capacitor of capacitance C. We don't know the value, we need to find the value. Now, you can see initially after charging, what is the amount of charge in the 2 microfarad capacitor? 24 microcoulomb. And when you connect it to the second capacitor, that amount of charge is going to be shared so that Q1 plus Q2 is that total charge 24 microcoulomb. Is that right? Yes. So Q equal to 24 microcoulomb is shared between them so that Q1 plus Q2 equal to 24 microcoulomb. Okay. Now, the potential difference across the 2 microfarad is 4 volt. Well, the potential difference across the 2 microfarad is 4 volt and its capacitance is 2 microfarad. Can you calculate the amount of charge on it now? When you connect them now like this, We are told that the potential difference across the 2 microfarad capacitor drops to 4 volt. So the potential drop across this is 4 volt. Its capacitance is 2 microfarad. Can you calculate the amount of charge Q1 on that? Yes, Q1 equal to C times V, where C is 2 microfarad, V is 4 volt, and that will be 8 microcoulomb. Now, what was the total initial charge? 24 microcoulomb. So, out of that, only 8 remains in the initial 2 microfarad capacitance. What is the amount of charge, therefore, in the second capacitor? The amount of charge on the second capacitor is 24 minus 8, that is 16 microcoulomb. Now, since the 2 capacitors are connected in parallel, you see they are now connected in parallel. That means if the potential drop across the first capacitor is 4 volt, the potential drop across the second capacitor also is 4 volt. Because when capacitors are connected in parallel, they both have the same potential difference across them. Therefore, for the unknown capacitor, we need to find the capacitance of this. For the unknown capacitor, now we know 2 things. What are they? We know the amount of charge on it. How much is it? 16 microcoulomb. We know the potential difference across it. How much is it? Equal to 4 volt. So, therefore, its capacitance C equal to Q over V. Q is 16 microcoulomb. Potential difference is 4 volt. Therefore, the capacitance of that capacitor is 4 microfarad. It's a very good question. And if you practice questions of that type, you will find it very easy to do problems of this sort. Okay, let's do another one. A capacitor carries a charge of 15 microcoulomb when the potential difference between the plates is V. When the charge on the capacitor is increased to 18 microcoulomb, the potential difference between the plates is increased by 6 volt. Now that means if the old potential is V, the new is now V plus 6. Find the capacitance of the capacitor and the initial and the final voltage. Try and picture the problem and see whether you can draw a diagram. A capacitor carries a charge of 15 microcoulomb when the potential difference between the plates is V. Well, we've got the charge and the potential difference. We have a capacitor of capacitance C. We have 2 situations about this capacitor. What are the 2 situations? The first situation is it carries a charge of 15 microcoulomb when connected across a supply, a battery of potential difference V. That's the first situation. Q1 equal to 15 microcoulomb when V1 equal to V. Therefore, we can write now C equal to C, the capacitance equal to Q1 divided by V1. Alright, what is the second situation? When the potential difference is increased by 6 volt, that means the new potential difference is, well, you can see that C is Q1 divided by V1. Q1 is 15 times 10 to the negative 6. That is 15 microcoulomb. And V1 equal to V. Now, this is the first situation. What is the second situation? When this V is increased by 6 volt, that means V2 is V plus 6. Then the charge, the amount of charge is increased to 18 microcoulomb. So Q2 equal to 18, V2 equal to V plus 6. That is the second situation. So in the second situation, Q2 equal to 18 microcoulomb. When V2 equal to V plus 6, the potential is increased by 6 volt. And we can write a similar situation. Will the capacitance of the capacitor change? No, the capacitance of the capacitor will not change. When you have a capacitor, no matter where you connect it, its capacitance will be the same and it is written on it. You cannot change it. So, you can write the equation for the second situation, C equal to Q2 divided by V2. There you are. And Q2 is 18 microcoulomb and V2 is V plus 6. So, how can you find the value of V? We need to find the capacitance of the capacitor. We need to find that C, and the initial and final voltages. In other words, we need to find this V, that's the initial voltage. Well, is there any way to find that V? Since both these quantities equal to C, we take these two quantities and equate them. Let's do that on the next slide. So equate the two quantities. Is that right? This is C in the second part. This is C in the first part. When you equate them, 10 to the negative 6 and 10 to the negative 6 will cancel. That means 18 multiplied by V equal to 15 multiplied by V plus 6. There you are. And distribute that and solve for V. You get V equal to 30 volt. Well, this is the initial voltage. If the initial voltage is 30 volt, what is the final voltage? The final voltage is 30 plus 6. So V initial is 30 volt, V final is 36 volt. What is the capacitance of this capacitor? You can see each of this is the capacitance. So all you need to do is, you can take this C equal to Q1 over V1. Take the value of V there and calculate, that will be the capacitance. So Q1 equal to 15 microcoulomb and V1 equal to 30 volt. Therefore C, the capacitance of that capacitor, will be Q over V. That will be 15 microcoulomb divided by 30 volts. That is 0.5 microfarad. You see? Again, that is not coulomb, this is capacitance. Therefore, this must be microfarad. Okay. Well, I think we have done enough number of problems for you to get familiarized with the concept of capacitor circuits. And you must be able to do all these kind of problems. And we are now going to go on to talk about electricity. Now, how can you produce an electric current? I will start that in the next lesson. All right? I will see you for that in a little while.